Assalamualaikum and good day class. Obviously, this is your fourth lecture in ES11 or Mechanics of Statics, okay? But before anything else, I highly encourage that you better print the file that I have uploaded these past few days, okay? So you better print the file for you to cope up or for you to follow this video, okay? So in this fourth video or fourth lecture, we will be talking about equilibrium, okay? Equilibrium. So, as we all know, this equilibrium, the concept of equilibrium, magagamit yung concept ng equilibrium all throughout your remaining years in engineering, okay? So magagamit natin yung concept ng equilibrium sa following courses or following subjects sa following higher majors. So meaning to say, you better understand the concept behind equilibrium, okay? Lahat ng bagay, dapat lahat ng bagay na nasa equilibrium is maintindihan ninyo because it is very very crucial in engineering. Okay? So sa mechanics, kapag yung isang body is in equilibrium, lahat ng forces acting on it is zero. Okay? Meaning to say, the resultant force R and the resultant moment are both zero. Meaning to say, yung resultant daw natin or summation of all forces is equal to zero. Okay? Yan ay isang condition or isang requirement sa isang physical body para maging equilibrium ito. Okay? Again, resultant or summation of all forces is equal to zero. But as we all know, considering na may summation of all forces at x, dapat zero, summation of all forces at y is equal to zero. Yan yung requirement. Dapat summation of all forces at x is equal to zero and summation of all forces along y is equal to zero. Kasi at the end of the day, yung summation of all forces, ito siya, is equal to square root of summation of all forces along x squared plus summation of all forces along y squared. Okay? That is in 2D. Pero kapag 3D, yung problem natin, that is may summation of all forces along z is equal to 0. And of course, yung nandito din is plus summation of all forces at z equals to 0. Okay? So, yan yung requirement, isa sa requirements para yung isang structure or yung isang physical body is in equilibrium. Next condition, dapat yung moment or summation of moment is equal to 0. Okay? Gets ba yun? Again, yung dalawang ito are dalawang requirements para masabi natin yung isang body is equilibrium. Those are summation of all forces equals to 0 and summation of moment is equal to 0. Okay ba? So next thing, kapag yung isang physical bodies are, as we all know, lahat ng physical bodies ay three-dimensional, right? Pero take note, kapag yung isang force ay nag-exist or yung isang force ay nasa isang plane lamang, pwede nating i-analyze yung structure na yan or yung body na yan as in two-dimensional. For example, this one. Okay? Wait. Let me change this. For example, consider this axis. Okay. This axis. So this is x, y, and z. Okay? X, y, and z. Can you imagine this x, y, and z axis? I do hope so. Okay, consider this x, y, and z axis. Yung ibig sabihin nun, as we all know, lahat ng physical bodies ay three-dimensional, right? Pero, as you can see in your handouts, kapag yung force ay nasa isang plane lamang, pwede nating ma-analyze ito as in two-dimensional. For example, let's consider this force as y1 and x1 and y1. Okay? So, meaning to say, nandyan. That is x1 and y1. Meaning to say, yung x1, y1 na yan, itong force 1 na ito, pwede nating i-analyze siya as in two-dimensional. Kasi, nasa axis lang siya ng x, y. Yun yung ibig sabihin nun. yung F1 na yan, yung force 1 na yan, pwede i-analyze natin yan as in two-dimensional since it only exists in one plane. That is XY plane. Okay? In XY plane. Pero, kapag yung isang body or yung isang force ay nasa axis ng tatlong ito, for example, this one, this is X2, Y2, and Z2. Okay? This is force number 2. Si force number 2 is nasa axis ng X, Y, and Z. So, meaning to say, si force number 2, i-analyze natin siya as in 3-dimensional. Gets ba yun? So, that is the concept behind equilibrium. Dapat summation of all forces is 0 and summation of moment is equal to 0. Okay? Now, let's move on with system isolation and free body diagram. Ito rin. Ang free body diagram, mamimit niyo ito sa lahat ng subjects niyo. That includes fluid mechanics, kasali na rin dyan yung mga theory of structures, yung mga design sa steel, timber, and stuff. Okay? So, basically, sa system isolation and free body diagram, yan yung behavior or yan yung epekto. I mean, i-draw natin yung epekto ng forces sa isang bagay. Not just effect. For example, kung ano yung itsura ng forces sa isang structure or sa isang body. To give you the better picture or clearer picture, let's consider this building, okay? Consider natin ang building na ito. Okay? Para mas ma-imagine natin. Okay. Actual building. Okay. Let's say for example sa building na ito. Sa building na ito, may forces dyan. For example, may force 1 dito. At saka may force 2 dito. Okay? For example, yan yung building na yan. May force 1 dito, may force 2 dito. Ito yung actual building. Yan yung illustration ng actual building. Pero kapag sa free body diagram or FBD, kapag i-draw natin ang building na ito in free body diagram, ang mangyayari dyan is ganito. Okay? I-draw natin lahat ng possible forces na exist. Those are the external forces. Example, this one. Pwedeng i-draw ninyo itong this one, itong sa baba or hindi. Pwedeng hindi or pwedeng i-draw. Okay? So, as you can see, may force 1 dito. As is natin yung forces na nag-exists originally. So, force 1, force 2. Later on, i-discuss natin yung typical type of structures at saka yung typical types of effects ng external forces. Consider this actual building, tapos yung FBD niya. As we all know, itong pagkakatay ng building na ito. This is what we call fixed, okay? So, fixed structure. Sa fixed structure, may mag-exist or may magaganap na external forces na external force along X at saka, along Y at saka external force along X. Okay? Tapos, not just forces, may moment din sa fix. So, as you can see, sa free body diagram, gineglect natin ito, gi-convert natin ito into its illustration through forces and moment. Okay? So, ito yung sinasabi nating free body diagram. If we are to look at the concept behind equilibrium, as you can see, di ba yung sabi natin dapat summation of forces is equal to 0 at saka yung summation of moment is equal to 0, right? So, if we were to consider this structure or this body, summation of forces at X is equal to 0, di ba? Yung sabi natin kanina. So, meaning to say, si F2 plus si Fx, di ba, lahat to sa right, minus si F1 equals to 0. So, yan yung ibig sabihin natin kanina na equilibrium yung isang structure. So, sa mechanics, yung assumption natin sa mga x-axis na forces, yung lahat ng papunta sa right is positive, yung lahat ng papunta sa left is negative. Okay? So, yun yung assumption natin. Let's consider summation of forces at y equals to 0. So, Fy is equal to 0. So, yan yung ibig sabihin natin na equilibrium. Next, let's jump into summation of forces sa moment. So, equals to 0. So, meaning to say, moment is equal to 0. So, itong tatlong equations na ito, yan yung key concept or key solution para ma-solve natin or ma-analyze natin yung behavior ng isang structure. Gets ba yun? So, next, consider natin, next example, consider natin yung actual, ito. Let's consider this one. Let's consider this beam. Okay, simple beam. Point A at saka point B. Okay? So, may force dito na, let's say, si force 1. Okay? Si force. As you can see, if we are to draw the free body diagram, meaning to say, ito-draw natin yung beam na ito, kasali na yung external forces. If we are to draw the free body diagram of that beam, as you can see, this is F1. Ito si point B, ito si point A. Ito guys, whenever you see this support, ang tawag dito is support, okay? Yung tawag dito is support. Kapag makita niyo yung support na ito ibig sabihin nito is hinge, ito na naman is roller, okay? But later on sa video na ito, i-introduce ko sa inyo ang iba't ibang types. I mean, different types of supports. But let's consider this simple beam. See, this is hinge and this is roller. Sa hinge, if we are to consider mechanics, sa hinge, may dalawang forces dyan na nag-exert. That is FAY at saka si FAX. Sa hinge, may dalawang components yung forces, along X at saka along Y. Pero sa roller, take note, isa lang yung nag-exist dyan, that is along the normal force. I mean, normal force sa surface. For example, kung yung surface natin is ganito, ito yung support natin. Yung support natin is ganito. Okay? O yung force natin is pahiga. That is normal. Okay? Normal to the surface. But if consider natin yung simple beam na ito, sa point A, may forces along X at saka force along Y. Pero sa point B, along Y lang. Pero if consider natin yung equilibrium, okay? Summation of all forces along X is 0. So meaning to say, if AX is equal to 0, okay? Equal to 0 diretso kasi walang ibang forces along X. Pero kung titingnan natin yung forces along Y, that is equal to 0. So may force sa AY, tapos may force sa B na pataas. Tapos, consider din natin yung F1. Okay? That is equal to 0. So, yan yung forces along X. Pero, may moment din is equal to 0. But since, sa simple beam na ito, walang moment, that is moment is equal to 0. So, yan lang yung concept behind equilibrium. So, sa next video, doon natin titingnan yung modeling the action of forces. Okay?